And we're live. Good afternoon, folks. Welcome to the next set in our Hangouts on air with Couchbase. In this Hangout, Matt Indethor will be chatting with John Lang, the architect, about the global secondary indexes and multi-dimensional scaling. So Matt and John are going to give you some insight on how this is unique to distributed database deployments and why Couchbase is so excited about this upcoming release. If you have any questions and answers, please feel free just to answer them in the YouTube question section on Google Hangouts, and we'll answer them as we go along throughout the show. And if you have any other questions, feel free just to let us know. Thanks. So over to you, Matt.
Hey, thank you, Laura. Hey, John, really appreciate your taking the time to come and join us today. And I know I had to, in fact, not everyone knows this, I had to pull John out of a meeting for today's Hangout, but I'm glad he was able to take a minute or two. So thanks for joining us. John, you're part of our engineering organization, and give us just a quick sense of your role. What is it you do on a regular basis here at Couchbase?
Yeah, hi Matt. So I'm the architect for secondary index. So secondary index is the new features that we have in our 4.1 release. And the main goal, right, for us having to, building this new infrastructure is to get us to get a better performance for one of the other features that some of you may already know is that we're also building a new query language called Nickel on top of our Couchbase. So as everybody who used database before, query and indexing are twin brothers, right? So we have better query capabilities, so we have also more advanced indexing capabilities that we build for Sherlock. And the main goal is for get a better performance, better deployment options, better scalabilities. So that's why we spent last couple of months trying to enhance a lot of what we have regarding indexing.
Yeah, you can be honest. It's been more than the last couple months. It's been like all projects, this has been a big one, but we've got some awesome new work coming out of it, right? So we're really excited about it.
Yeah, we're really excited about this.
Great. Hey, so I know 2i is sort of, correct me if I'm wrong, but we call it 2i, secondary indexing, the new secondary indexing capabilities in Couchbase. So we're adding another service to Couchbase as a cluster, right? And so while the way our developer users will experience the new secondary indexing is through Nickel queries, that actually meant that you and team had to fit it into the overall Couchbase cluster architecture and this idea of one of the things that we have in 4.0 called multi-dimensional scaling. So can you give us just a quick sense of what's different, say, in multi-dimensional scaling versus, say, what we would have done in 3.0?
Mm-hmm. So for people already familiar with Couchbase, right? In 3.0, we have many database services already, right? We have caching services, we have views, and we have a bunch of other stuff, right? So what we have for 4.0 essentially is piggyback the ideas that we already have, but we break it up into a little bit more granularity. For example, let's say that we have our data services is that what you guys, most of you will already be using, right? You have the Couchbase bucket, and we create a bunch of other services like query services and indexing services along with it. And the whole idea basically is that it's to give the users or the administrators to have deployment options to say, hey, I have all these servers running. And I want to know, like, for example, there's some customers who want to say, hey, I actually, need more nodes for my Couchbase bucket, but I'm using, but I mostly it's a write-heavy applications, but I do actually need query, but the query maybe only 20%, right, of my whole workload. So they can partition their basically they can provision their cluster in such a way, hey, maybe they're still having 80% of the time is 80% of the resources is still allocated to the to the data surfaces, and they can actually allocate the other 20% of the resources to nickel as well as indexing. So there's a lot of flexibility in terms of how you can adjust your cluster resources based on the workloads that you have. Or you can turn the other question is that if you have a lot of read-heavy nickel query workload, right, then you can actually allocate more resources or more nodes to run for query and for secondary index. So we just basically make it more granular in terms of how we already architect our system in terms of services and have the options to deploy it, right? So you can tailor to your workload.
So this means like in 3.0 and prior, every node had every service on it, and while in 4.0, correct me if I'm wrong, because I know one of the things that we're proud of with Couchbase is that we have a single node type. We'll continue to have a single node, single package installation, but what the administrator will be able to do is have more granular ability to kind of separate out what nodes are responsible for what. So if I, as an app developer, write something that's really heavy on query, then I can toss in some more query nodes, basically, and I can come up with a different kind of query node for that, right?
Exactly.
That's cool. Okay.
And also, we can also do certain things. For example, we can adjust different types of workload. You may want to use different partitioning. We call it workload isolations in the sense that, for example, let's say that for people that are using Couchbase right now, a lot of time they're using hash partitionings for Couchbase bucket. But then when it comes to query, it's probably better for data to be co-located. So we can actually, by separating services, we can also separating workloads so that we can say, hey, the secondary index, we can actually cluster the data more closely together so we can get you better performance. So there's two sides of it. One is partitioning the services for deployment so we can tailor-made, right, in terms of what your workload resources is called for. The other one is that by separating them, we can also, separating services, we can also partition the data in a ways that can tailor fit to how your application wants to access the data.
Got it. Oh, that's pretty cool. So before we started here, I know you sent me over a couple of diagrams, and I want to pull those up because it might help. One of those, for example, I know you were telling me there's something a little different about the way we do do range partitioning, and that's kind of going to be unique, really, in this world of NoSQL. That nobody's currently doing it like that. So let me pull that up. Here's the diagram that you shared with me earlier. So John, tell us what's going on here. I know we have. So maybe you can kind of use this to explain what's going on with range partitioning.
Yeah, basically what we see in this particular diagram is it basically speak a little bit to like what I mentioned before is with range partitioning you can basically you as an administrator as the users, right, of Couchbase can decide how you want to cluster your data. So in this particular example, at the bottom you see actually there's like 3 indexing services, and for these 3 and for each index services, you have like 1 index in there for the last name. But what this diagram illustrates is basically say, hey, I can actually break up. So let's say that you have a data bucket, right, and you have a set of documents, and each of these documents has a field called last name. So I want to index on this last name. At the same time is that I want to have some ways to control clustering. So I want to say, hey, from A to I, for this range, I want to put in 1 node, and from J to R, I want to put in on the other node, right? So you can basically cluster your index in such a way so that it makes it faster and easier for your query to access to that data. But keep it in mind, right? So your Couchbase bucket is still using. I mean, I guess if you continue to using hash partitioning as your partitioning scheme, that's still going to stick for your data bucket. But we have independent partitioning in this case, right? Just for index, and then for each index, you also have a very fine-grained control to say how you want to cluster the data. So I cluster that in 3 different ranges, And you can see on the top I have 2 different query, and each query can basically go and look for each partitions. So
That's cool.
Yeah.
Yeah, I also had this other diagram that you gave me, which is really kind of talking a little bit more in detail about how the query isolation happens with GSI. Can you kind of describe what's going on here?
Yeah, it's a little bit the same as, as described. So basically here is that you have your transaction workload, right? So you have your get and set ops, right? That you actually set, doing your memcache get set and writing updates, right, to your documents in your data buckets. So that's your data surfaces. So your document is going to be hash partitions across these different data surfaces, and for discussion we have, let's say that each of these data surfaces is reside on one of the node in the cluster. And in 3.0, if you recall, we have built a very fast and high throughput interconnect bus, right, that can use to connect the nodes within the cluster. So that's called DCP. And we're using the same replication protocol to replicate the data into different index surfaces.
Yeah, and just to interrupt for a moment, if I remember correctly, DCP is the database change protocol. So as you mentioned, it's the thing that we use for both our cross data center replication as well as intra-cluster replication. So you've just leveraged that same super fast interface there, right?
Exactly.
Okay.
And in this case, you see that once we actually transition from a transactional workload to query workload, we can basically reshared or recluster the data, right? So that in this particular cases, I have 2 index surfaces, and I can build an index based on a certain range, and then the query surfaces can access to those indexes. Is better than some of the other other technologies outside of Couchbase, right? Because a lot of time is you can see that some of our competitors, for example, they may not be able to partition index and the data differently. If you choose to use hash partitions, and index also has to be a hash partition, or if you choose range partition, index also has to be range partition. But there's no separations between your transaction workload can do one way to partition, but the query workload can do the other way. And the whole idea why we want to say, hey, why we need to have different partition, because we do actually have very different types of workload here. Because on the left-hand side, you see that there's a lot of set operations, right? We want to use hash partitions so that we can balance out our write more effectively across the data surfaces. But on the right-hand side, we have a query surfaces, and as we all know, right, to get fast. So we have, this, so that we build this infrastructure to provide all the possibilities that you can kind of like tailor-make how you want to deploy your services and how you partition your data, so that it can fit into the performance characteristic that your applications need.
Got it. So just super simplifying that, I think what basically what you're saying there is when you want to scale out all those key value services, aggregate, spread it across the cluster as much as possible. But obviously, when you're trying to query a range and say, what are the documents I'm looking for in this range, you don't want to touch everything and then have to remerge the results, because if I always liken this to if you remember college, I do. Right, you got to go right at the operational complexity of a given algorithm. The operational complexity of an algorithm that's going to have to touch every node and then do a merge sort is basically going to be an O log n with a fan out of O log n. And what we've done with the architecture you and team have built with 2i is we'll just be able to go straight to the 1 or possibly 2, depending on the size of the range query, place where that range exists. And the app developers abstracted away from all of that. So they just need to do the query, and then Couchbase does the right thing, as long as the indexes have been designed correctly, correct?
Yeah, exactly. That's a very good summary.
Cool, great. This sounds awesome. Looking forward to seeing people build apps. So then I guess another question is, it is still a distributed system. So just one of the good thing about a non-distributed system is that if it fails, it all fails together. The bad thing is that when it fails, it's not available. And one of the things that we always work hard on here with Couchbase is making sure that we have high availability options. So what do we do with global secondary indexes to maintain the index availability?
So the way that we do it right now is basically you can still build indexes. So if you build multiple indexes with the same definitions, we all treat them as the equivalent, so that during query, we can see which indexer has the lesser node and then forward the request to that particular index. And as an administrator, right, you also have an options to control how you want to place the index across the cluster. Or if you want us to decide, if you want us to do it, I mean, we will also we can also have automatic index placement. So, for example, let's say that in your cluster you have 5 index surfaces on 5 different nodes. And when you create an index, we can basically, put it on. We can spread it out for you. That's one option. But if you want to actually have explicit control, that's another. You will be able to do that as well. But the idea is that if you do have 2 indexes that have the same definitions, if one fails, then we can automatically route the request to the other ones. That will, that's the way that we can achieve high availability.
Got it. So from a developer perspective, there's again at administration time or operations time, you have to kind of make some decisions about what kind of failures you're willing to accept. But as long as you set that up and size things correctly, nodes can fail and the system would keep going with as few hiccups as possible.
Correct.
Great. So one other thing that comes up though in this context is the idea that maybe that index itself. I remember reading a little bit about when you define an index, and this is kind of also a unique feature. When you define an index, you can actually pass some additional parameters in on the index definition for partitioning. So how does one approach that? So there's the availability side, but also there's the scalability side.
Yeah, there's the scalability side in the sense that, let's say that if you end up to have like a very big index, right? I mean, and you want to actually spread it out across multiple nodes so that you can actually, do better load balancing, right, on your root traffic. So you have a ways to do it. So when you create an index, we call this where clause, and then basically all it has is that basically you can say is an expression. So basically you can say, hey, I want to create an index for using previous example, right, for last name. And you can say, hey, if my last name is between A to J, then I want to actually place it in one node. And if it's from case to Z, for example, then I'll put it on the other node. So that helps you to provide a way if you know that there's certain index, for example, that actually has high, require high throughput, then you can basically do that. And you can also replicate a certain range. For example, let's say that you have U.S. states, right? You have your index of U.S. states, and you may say, hey, if it is state is California or New York, you know that typically that has probably higher traffic because there's more populations, right? So you can say that, hey, I want to create another index which is just for California or New York, and then we will basically load balancing, between them. So you can say, hey, I know that my load is, I need 3 indexes to actually, to sustain my load for California and New York. Then you can basically just create 3 indexes just for that range, but you don't have to build the index, right, for all the 52 states. So you can basically fine-tune your your load and the throughput based on the particular range.
So I know, for example, game developers. I'm just kind of making this up on the fly. So tell me if I got this correct or not. Game developers. I don't know if you're aware of this, John, but one of the things that game developers, we have lots of game devs on Couchbase. One of the things that they'll frequently do is they do their first deployments to a place like New Zealand because they speak English and the population is small, and you have a better opportunity to fall on your face, I guess, with a small population. So one could actually, if I have this correct, one of the things that somebody could do is they could actually create an index, and they could have, say, an attribute of a document that says if it's a New Zealand document, then it's going to this index, and then when the query comes in, it'll direct those just to that index.
Right.
And that index can stay nice and small, and then I can experiment a bit, and then before I go to deploy to, say, the United States or something like that, or even China. Great, okay, I'm going to deploy to China. I'm going to need some different nodes for that. I can even, obviously, we're getting into a much more complex case for the operator because now you're having to decide where you're placing things. The default is that things are automatically placed, but somebody could actually do that, right? Size nodes for the United States index and define the index, and everything would work just fine. The application developers abstracted away from all those details.
Yeah.
Very cool.
Always. Sure.
Sorry, go ahead. I didn't mean to step on you. Sometimes there's latency on these Hangout calls.
Yeah. No. It's yeah. What you say exactly right.
Awesome. Hey, for folks on the call, I know there is an option for you to ask questions. So the Q&A module is enabled. So if anyone has a question for John, by all means submit it, and I'll gladly read it out here on air on the Hangout. Just moving on here briefly. So that gives a sense of how we do partitioned indexes. What happens if I go to create a new index and I don't do any of this explicit work, and say I had a couple. I'll give you a scenario. Maybe I have two nodes that are the index nodes previously, and then I add a new node, and that new node is also an index node to the cluster, or has the index service. I should say it correctly. Every node is of the same type, but they can have different services. So I add a new node, and that node I enable the index service, and then I go create a new index. What happens in that case? Is it going to automatically balance those indexes? Is there anything special I have to be aware of?
So right now is that when you create a new index, it will basically goes to the least populated node. So you add new capacities, right? You add another new index services. Any new index that you add will goes to the new node. But the existing node, the existing services, the existing index will still remain on the same node that was already built on.
Got it. Okay, so if I'm scaling this thing up, I deploy a new version of my application. That new version of the application has some new indexes with it. Then Couchbase in that case, Couchbase would kind of optimally handle the index deployments. Correct?
Yes, correct.
Cool. And if I want to get specific, maybe I have specific resources that I've allocated within the cluster. Is there some syntax or something that I would use to specify how I want those indexes deployed on the cluster?
Yeah, there are ways that you can control where you want to actually put this. Put the index. If you add new services in, you can have fine-grained control to say, hey, I want this index to be on these new services. So that can be an option. So when you create an index, you can specify, the node that you want to put the index on. But again, right, this is options. So by default, that the developers or administrators does not have to know about it or worry about it. But for very specific cases, you want to have very tight control in terms of your clustering nodes. So we do actually give you that ability.
Got it. So there's a question here actually from one of our viewers. It's from Alex Durandish. Hey Alex, we've met in person. I know you came out to Couchbase Connect. Great to see you there. The question is, how does this indexing work with a mobile world? How does a mobile service, how does mobile calling a service know which index location to hit? And I actually know a little bit about that, but I'll let John go first, and then if he needs some backup, I can jump in on that one.
Yeah, I think right now it's still two different technology, but Matt, why don't you go ahead?
Yeah, no worries. Yeah, so Alex, the quick answer is for the most part at this point in time, when you build a mobile app, it will go through Sync Gateway, and Sync Gateway, because of the era in which it was designed, it uses views, and Couchbase views at the moment have some overlap, but not a lot of overlap with the new secondary indexing. You can certainly imagine that in the future we're going to plan to converge some of these things so that they'll all come together. I guess there's good news and bad news here. The good news is that everything that worked with 3.x for Sync Gateway for a mobile app for Couchbase Server is going to work for 4.x with Couchbase Server. The bad news is that at the moment, Sync Gateway is not going to take advantage of any of those new features, but you can certainly imagine that we'll be adding that in the future. That does actually kind of prompt an interesting question, and John, I know this is not necessarily your area of expertise 100%. This is in part from Query, but I know it's been in your thoughts. So I know that we still have, so that when you're deploying on Couchbase, you still have, actually through Nickel, you have the ability to use both index types. Is there, off the top of your head, and I know to some degree we're still learning here, and it's very workload dependent, but off the top of your head, is there a scenario where it makes sense to use the what we call GSI? I'm starting to learn at Couchbase we're really good at creating acronyms. Global Secondary Indexes, which is John's project, the 2i project. Is there a scenario where you would use GSI versus a views-based index, just for somebody who's new to Couchbase and trying it out?
Yeah, for view index, I mean, there's a couple of technologies where we have views, right? We have view index and we have GSI. So for view index, typically it works better if you have index that require higher update rate. And for GSI, it works better with index that require higher read throughput and low read latency. So as Matt just mentioned, right? I mean, the world is going to different technologies going to combine, in the future. But right now is there are different use cases may work better for example, if you say that indexes probably works better with view indexes, and if you want index, for example, for quick lookup or for smaller scan that you just want to scan for, say 500 rows or something like that, right? It's better to use a GSI.
Cool. Yeah, not to put you on the spot, John, but I know you and I talked about this earlier, and you said you might be able to show off what it takes to add some index nodes. Do you have something that maybe you can show us?
Yeah, sure. It's a very simple demo, so let me see. So
sure.
Let me try. Hold on for a sec.
And while John's getting his screen sharing going and so forth, remember, anyone out there, if you got questions, please go ahead and submit them on the Q&A, wherever that is on your screen, and we'll certainly answer them. If you're watching me in a recorded form, then you can ask on forums.couchbase.com, or you can ask over on, or you can go post to the Hangout on Google+, and we'll find it. So cool. Whoops, I see myself.
Okay, do you see my screen?
I do indeed, yeah.
Okay, so let me see if everything is still up. Okay, okay,
So
everything's
this is
still up.
like probably a today build of 4.0 or something like that.
It is today build. It's just on my laptop, today build on 4.0, and I just create a very simple demo. So right now I have a single cluster with just one node right now.
Yep.
So this node has actually two surfaces. It's at the data surfaces, which holds the Couchbase bucket, and also it has the query surfaces in there. So first thing I'm going to do is basically just add another node to this cluster, and that will have the index surface.
Okay.
So let me see.
Got to remember the IPs.
Right.
No worries.
Just in case, demo Jenks, I'll just copy it.
Yeah, yeah.
So here what you see is that, there's something new in Photo is that you have different chat box for different surfaces.
Mm-hmm.
And you can actually run all the surfaces on one node, but you can decide also, we can separate them if you just want to run one or two surfaces. So since I already have a data surface and query surface, I'm just going to run just the index surface here.
Okay, cool. So basically, this is the same. Oh, also, sorry, I'll let you finish here.
Okay. So after that, it asked me about how much was the RAM quota for my index surfaces. I'm just going to use a default. And now I just need to do rebalancing. And what you see is that now I have two nodes, right? And there's the original node, and now I have an index node. Okay. So Matt, you were trying to say something?
Yeah, yeah. I was just trying to guess at where it was going to go next. Now, that rebalance was super fast, probably because that type of rebalance doesn't actually require any data movement, correct?
Exactly.
I see. I see.
Yeah.
Cool. Sorry. Go ahead with the rest.
Yeah. Okay. So I have already some data in my data bucket, but let me check. So it's very small. I just have 10K just for demo. And now I'm going to this is my nickel shell. Let me actually go and create an index. So here what I'm doing is that I'm creating the index on the field called company, and this is for the default bucket, right? Oops.
Yep.
Hold on for a second.
So that is you requesting nickel, talking to the nickel service through the command line CBQ that then is within the cluster going to give some directions to the indexing service to do indexing.
Yes.
Cool.
Okay, so let me go to the index tab. So what you see is that there's a new index just created, and it's created on this node 9001, right? Which is the index node we just actually add to the cluster.
Okay.
Company, right? If you drill down to it, you actually see that it's a create statement that I have. And we have an option. Sometimes, you see that it is. We say if you look at this, the statement is say using GSI.
Mm-hmm.
Sometimes, like Matt, you mentioned earlier, we can create an index using view, and you will see if you create an index using views, we will say that using views. But obviously, if you don't specify anything, then you will create a GSI index.
Got it.
Yeah, you can go to your data buckets. If you drill down into data buckets, this is something you guys are all familiar, but there's something new for 4.0, which you see is that there is some stats that is for the index that we just created. So here is that you can look at. We don't have any scan going on, but you can see that there's a disk size. There's a what is the amount of data on the disk, the amount of data in memory, and so on and so forth. So let's do that. I mean, since we created the index, let's do select star form default where company equal to Wipro. So there's about 3,000, right? So let's do that.
So now we'll just go get the first 10 or something like that, I guess, is what you're going to do next.
Just get the first 10.
Cool.
So, pretty fast. 11 milliseconds to fetch it. So it's definitely, I mean, for people that has used so I mean, the whole idea is basically instead of actually, I think in this particular case we have only one data node, but imagines that in your typical deployment you may have, say, 5 to 10 nodes. So even you have 5 to 10 nodes, right, we can still aggregate all the index data into this single node so that you can still get the low latency that you will see here, right? So we don't have to go and scatter across 10 nodes and try to figure out like where the data resides and extract them, and like you just mentioned, right? And then you have to sort it and so on and so forth.
So tens of nodes are going to be just fine. I'm going to put you on the spot. Can you run that a couple more times? Then let's go back and look at the console. We should see some scans, right?
Sure. So let's go back. Yeah, you see there's some peak over here. That's basically the response. Yeah.
And if you click on that, I think we should see it up above. So we probably didn't even. So you see that in each one of the dots on that chart. Since we're looking at a minute, we have 60 points there across the bottom. So it scanned about 1,200 items a second, approximately, for each one of those across that index. And because it's range sorted, that's where we get all that really low latency for those kinds of queries.
Exactly.
So
cool. Sorry.
Just to interrupt you for a second, I've got another question coming in. So thanks again. It's from Alex. So thank you, Alex. Thanks, Matt, for answering the last question. One more. If I want to have two-dimension indexes, one based on location of data and the other based on language of the content, do I need to make changes to make my data services to hit the right index?
We have another technology. So right now for the GSI index, it's a single dimension index. But we do in Sherlock, we do actually have geospatial index, multidimensional index. So maybe Matt.
Sherlock, sorry to interrupt, John. Sherlock is the code name for 4.0. So we've told people about that before, but in case you're wondering, what the heck's Sherlock? Yeah.
Yeah. So yeah, I think in that cases, it depends on when you say that whether the application needs to change. I mean, applications, if it wants to take care of our geospatial indexes, I think you do have to actually definitely make some changes to make use of it. But the good news is that that technology is going to be available. So hopefully your application can benefit from it. So Matt, maybe that's another Hangout idea for you.
Exactly. We should do a hangout on geo and what we're able to do with multidimensional indexes.
Cool, thank you. So John, just one final question there. Are there any limits on the number of index dimensions?
Index dimensions right now is 1. We don't have any limitations of the number of index, right? But for every single index right now is a single dimension. You index on a single field. Having said that, what we have is something called Composite Index. So it supports different types of query, because we're not going to say for geospatial you're looking for intersections, right? Essentially, you're looking for an area where where the data fit into a query, right? So, but what we have is that we can have a composite index, which is very similar to what you would get, what you have for relational database as well. So what it means is that the index itself can be used to index multiple fields in a document. But it's a little bit different from, say, a geospatial query in this particular case, because the query itself is still a point query.
Yeah, I think another way to put that to Alex is typically if you're building an index that is, say, you want to find everyone with the first name from A to A. That typically the data structure you use for that type of index is a B tree or a B plus tree or something like that. And then Alex, what'll happen is when you go to design an index type that you use for multi-dimensional indexes, that's actually technically an R-tree index. And as an extension to other parts of Couchbase, we actually have added that. It's been technically in the 3.0 as an experimental feature, but it's being promoted as a production feature here in 4.0. So we'll definitely get a Hangout going in the future, but that R-tree index is the one that allows you to have multiple dimensions on the index, and there are a few different ways that you might be able to use that. It's not just geospatial, although it works really well for that. But John, the one that you'd mentioned actually is pretty cool too, in that you can now the predicates that are passed through that query for that index, you can actually keep that index. You can have multiple things, so you can keep that index pretty well constrained to the type of queries that you're going to be receiving. Correct?
Exactly.
Awesome. Great, John. Was there anything else you want to show us on the demo, or have we wrapped that up? We don't see you. We just see your board and cluster there.
So do I need to grant the control back to you? How does that things work?
No, you just got to go back into the Hangouts app and then turn off the screen sharing. Yep, there it is. You can say stop right there above my head. Yep, I see you again.
I'm sorry.
No, that's okay. I made John install a Hangouts plugin to do this. He's a Hangouts newbie. Well, I want to say, I think unless there are any other questions from the audience, I want to say thanks so much for joining us here today, John. Laura, any other questions or anything you want to do to wrap up?
So there's no more questions, but I do want to just show you guys some ways to keep in contact with us. So just let me share my screen with you for a moment.
Sure. And your video was off, so you were the glowing Couchbase logo.
Cool. So just to kind of show some stuff that's actually happening here in Couchbase, we have an event taking place on October 6th in New York, Couchbase Live. A series of talks and workshops will be taking place that day. Not workshops, but in-depth interactive talks that will be taking place. If you're looking to find out our nearest Couchbase meetup, have a look online. We have a series of events taking place from Seattle, Portland, San Francisco, Silicon Valley. We're all over the place, and we'd love to get to meet our community. And if you really want to keep up to date with us, please just sign up to our developer newsletter. It comes out once a month, and it talks about technical content, some of the blog posts that we're currently working on, and maybe some tips and tricks that the guys have actually found out recently and help you use Couchbase. As always, if you're ever looking to get in contact with us, please just drop us an email to community@couchbase.com. We're always looking for suggestions on these kind of Hangout topics. So I think from tonight we've actually learned about a new topic that Matthew and Matt will probably schedule over the coming weeks. And if you're ever looking and you get stuck with questions on Couchbase, please just have a look on forums.couchbase.com. We're always idling there to help, and if you have any questions, we're happy to help. Thanks.
Great, thank you, Laura, and thanks, John.
Thank you, folks.
Thank you very much.